These are the practice problems for lesson 7, which is entitled No Bending or Stretching. And this first problem, remember that the idea is to realize that these are rigid transformations. So in this first problem, they're asking you, is this a transformation from P to Q as you move P to Q? And it's not, because the angles change, and I don't know if the lengths of the sides change, but the angles clearly change. So it is not a rigid transformation, because the angles have to remain the same as well as the lengths of the sides. If I turn it, rotate a little bit, I can't make it fit. Just cannot make it fit over Q, so it is not a rigid transformation. The next problem, they're just asking, what's the transformation that takes triangle A to B? Well, if you slide triangle A up 2 units along the y-axis and to the right 3 units along the x-axis, you get there. So that is a rigid transformation of triangle A to B. The angles are all the same, and the lengths of the sides are the same. Problem number 3. This is not a rigid transformation going from A to B, because again, you just can't make A fit over B. It changes. The angles remain the same. They're all 90-degree angles, but the lengths of the sides are changing. So it is not a rigid transformation, however I turn it. And the last problem, there's 3 parts to it: a translation, a rotation, and a reflection. And this is just review, asking you to do each of those things under the given conditions. So the first one is to translate the shape so that A translates over A prime. So you're just going to move A down 1, 2, 3, 4 units, and to the right 1 unit. So now A has landed over A prime. So that is a rigid transformation. It's a translation of A to A prime and the related figure. Second problem, oh, actually, I forgot. It's always a fun idea to connect the corresponding points, and for translations, it turns it into a prism. A prism is just a translated copy of the base. So the blue part is the base. The blue quadrilateral here is the base, and it is translated to the red quadrilateral. So that is a translated copy of the base. And yeah, it's kind of a neat special effect there. It goes from coming out of the page to going into the page. And the corresponding sides are connected by parallelograms. So these parallelograms connect the corresponding sides. So this is a prism, a quadrilateral prism. Next problem, they want you to rotate this image 180 degrees. And rotation 180 degrees for C is pretty easy to see. It's just drawing a straight line through B. Actually, around B is what they want you to rotate it around. So draw a straight line through B, and it's just 2 units on the other side. So this is 1 unit, 2 units, and this way it's 1 unit, 2 units. The other 2 are a little bit harder. Just draw a straight line through A, through B, and it will locate on the opposite side, and the same with D. But exactly where, you can count to check that. So if I count down 1 unit, and then in the direction of rotation 2 units, I'll get to D. So if I count up 1 unit, in the direction of rotation 2 units, you get to D prime. So there's D prime. And to locate A, count down 2 units, and to the right 1 unit, and then go 180 degrees around B, and do the same counting up 2 units, and to the right 1 unit, and you end up at A prime. So there are the 3 points. Connect them all, and that is a rotated copy of B, 180 degrees. And you can see that they all go through point B, and they're directly on the other side, 180 degrees on the other side. And the last problem is a reflection of this image over the line of reflection, which is labeled I. So you have to Draw lines that are perpendicular to each of the points through the line of reflection. So that's what I did first, and this is doing this in Docere. And that allows me to identify these points of intersections. I'm going to put a point right there for each of those. And then I'm going to measure that distance. I'm just going to take that distance and move it to the other side. And that's going to locate those 3 points on the other side. So place a point at the end. So now these are each equal distance from the line of reflection, but on the other side of that line of reflection. Now you could just count the diamonds. This is 1 and a half, and this is a half and 1. This is 1 and a half and a half and 1, and this one is just one of those diamonds. You could count it that way, or measure them with the lines. Connect the lines, and now if you connect the corresponding points, for reflections you get pretty nice figures if you shade them in. So I'm going to connect each of those corresponding points. Just going to move this down and shade each of those in. And you get a nice image when you do that. So this is a reflected copy of that image.